Good morning. Good morning. Good morning. Voice and everything clear? Okay. Okay, so last concept I discussed about the thermal capacity or heat capacity. Next is what? Okay, water equivalent. Okay, so up to the heat capacity, thermal capacity that I said it is a heat required to raise the temperature of a body by unit. Then formula also we got the H is equal to ms, or we can say the H is equal to Q by delta theta. Okay. Now what is a water equivalent? So one thing if I ask, do we know the specific heat of all the substance, all the material in the world? We don't know, because like suppose I'm asking what is my body specific heat, so we don't know the body specific heat. Yes or no? Means all the substance, if I'm asking, we know the specific heat, so we can say no. But water specific heat we know. Water specific heat we know. So why we introduce the concept of water equivalent? So listen carefully. Suppose I want to increase the temperature of, okay, listen, I want to increase the temperature of any body whose mass I have taken MB and specific heat I have written SB. I want to increase the temperature of any body by delta theta. Suppose I want to increase the temperature of a body by delta theta. Okay. So to increase the temperature, I have to pass some heat. So suppose I am passing the heat Q. Okay. So again I am repeating, any body, we want to increase the temperature by delta theta. Then for that we are passing the heat, and that heat I am taking Q. Okay. Then what is the meaning of water equivalent? Parallelly, I am taking the some amount of water, some mass of water. Okay. By changing the mass of water, you will get the mass of water which will absorb same amount of heat for the same temperature change. Two things we have to remember in the water equivalent, that has to be same. One, amount of heat absorbed by the water equivalent as well as body. Heat will be same for same temperature change. Delta theta has to be same. Now I am repeating. Suppose we want to increase the temperature of any body by delta theta. So for that we are passing the heat Q. Then what is the meaning of water equivalent? Now, if I took some mass of water, that will absorb the same amount of heat for same temperature change, So that mass of water is called water equivalent of the body. That mass of water is called water equivalent of the body. Everybody got? Again, I am repeating. What is a water equivalent? Water equivalent is the mass of water that will absorb same amount of heat for the same temperature change as that of body. Okay. Everybody got? So what I said, water equivalent means it is a mass of water. Okay. And heat absorbed by this and heat absorbed by the body will be equal for same temperature change. Okay. Now, who will say in this, whatever the quantity I write or whatever the quantity I write on the board, in this, which quantity represent the water equivalent? Whatever quantity I write on the board, which quantity represent the water equivalent? whatever I write on the board, which quantity represent the water equivalent? Tell fast. Whatever I write on the board in this, all the different quantity I write, delta theta, MB, SB, which quantity represent the water equivalent? MW. This is the water equivalent. So what I said, MW, it is the mass of water that absorb same amount of heat for the same temperature change. This everybody got? Okay. I think everybody got given the right answer. That is the MW. Okay. Now listen. Suppose I want to increase my body temperature, or any body you can take. I want to increase the temperature of any body by 2 degrees C. Okay. I want to increase the temperature of any body by 2 degrees C, but I don't know the mass of the body. I don't know the specific heat of the body. I want to increase the temperature of any body by 2 degrees C, but I don't know the mass of the body. I don't know the specific heat of the body. Okay. But I know the body water equivalent. I know the body water equivalent. Okay. Everybody getting? So what I said, I want to increase the temperature of any body by 2 degrees C, but I don't know the mass of the body. I don't know the specific heat of the body, but I know the water equivalent of the body. Okay. So if I'm saying how much heat the body will absorb if we want to increase the temperature of the body by 2 degrees C. So to rise the heat, to increase the temperature, how much heat required? Ms delta theta. But I don't know the mass of the body. I don't know the specific heat of the body. Only I know delta theta. What is the delta theta I required? 2 degrees C. Okay. Then what but I know the water equivalent. Then to get the heat, I will go to the water equivalent. Okay. I know the body water equivalent. So I will find the heat from the water equivalent. How? MW, SW, delta theta. Because what I said, for water equivalent, heat and delta theta will be same. And specific heat of the water we know. Okay. So even we don't know the mass of the body, we don't know the specific heat of the body. But if we know the water equivalent of the body, so heat absorbed by the body, we can find by its water equivalent. Okay. Everybody got? Tell fast. So for water equivalent, what I said? It is the mass of water that absorb same amount of heat for same temperature change. So water equivalent of a body is the amount is the mass of water that absorbs same amount of heat for the same temperature change. Okay. Everybody got? Now listen. In some book they are writing maybe you learn also. Some books they are writing the water equivalent formula. Water equivalent formula they are writing as a MS. Okay. Why they are writing and what is a mistake in that? Okay. That I will show. So they are writing the water equivalent. Maybe you learned also water equivalent formula is the MS. Okay. So basically, if you are taking the water equivalent formula is the MS. So one thing you will get confused from the unit also. MS means mass you will take in gram or kg. Specific heat you will take the calorie per gram degree C. So unit will come calorie per degree. MS I got the formula for the thermal capacity. MS formula I got for thermal capacity. Same formula they are giving in the water equivalent also. Okay. So one thing what I said, if you are using MS, so you will think the water equivalent unit is the calorie per degree C or joule per degree C. One mistake. Okay. And numerically also it will be wrong. Why? So I said what? For water equivalent, what we have to remember, heat absorbed by the body and heat absorbed by the water equivalent is same. So Q I can say what? If I am writing for body, then I will write MB, SB, delta theta. Everybody got? if I want to change the temperature of the body by delta theta, how much heat I can write? MB SB delta theta. Same heat its water equivalent will absorb. So that I can write as a MW SW delta theta. This relation everybody got or not? What I said, heat absorbed by the body will be equal to the heat absorbed by the water equivalent for same temperature change. Okay. So this relation one you have to remember. By the definition directly we can remember. Okay. Now in this relation, whatever I write, what is a water equivalent? In this relation, what is a water equivalent? MW. Now, if they given the heat absorbed by the body they given, and they are asking water equivalent. So I will use Q is equal to MW SW delta theta. Okay. Then I can find the water equivalent. If suppose they given a body absorb 400 calorie of heat for the 2 degree C temperature change. What is the water equivalent of the body? So heat absorbed by the body will be equal to the heat absorbed by the water equivalent. Okay. MW I have to find, delta theta I gave. Okay. This everybody got one type of problem. Second, if I'm using these two, so from this delta theta get cancel out. So what I can write? MW SW is equal to MB SB. This everybody got. Why? If I'm using this and this, so delta theta will get cancel out. When delta theta will get cancel out, then I will get MW SW is equal to MB SB. This everybody got. Now this relation you have to remember. What I said, no need to mug up any formula for the water equivalent. This relation you have to remember. Q is equal to MS delta MB SB delta theta, MW SW delta theta, or MW SW is the MB SB. Okay. Up to this, okay? Now, if I'm asking what is a water equivalent formula, then here I got MW is equal to MB SB by SW. Okay. Now listen, why they are giving the formula in the books? Why they are giving the formula MS? Okay. So we know that what is a water specific heat? Water is specific heat in the calorie per gram degree C. In that unit, what is a water specific heat? 1. So by default, they are taking the water specific heat is 1. SW they are taking 1. Then formula is coming MS, mass of the body, specific heat of the body. Why they are giving the formula MS? Why? Because they are taking the water specific heat is 1 calorie per gram degree C. So it is 1. Then I will get the water equivalent is the MBSB, means mass of the body into specific heat of the body. But specific heat of the water is 1 in the unit of calorie per gram degree C. In all the unit it is not 1. Okay, so that is a one mistake we can do. Everybody getting or not? So that's why what I said, if you are mugging the formula MS for the water equivalent, no need to mug up any formula. We have to remember the relation Q is equal to MB SB delta theta is equal to MW SW delta theta. By using that relation, I can find the water equivalent. And according to the unit of S, according to the unit of SB, we will put the value of SW. If suppose SB I have given in joule per kg degree C, so SW I will also put in the joule per kg degree C. That value is 4200. Last class I said. So specific heat of the water is 1, but in a particular unit, calorie per gram degree C. Everybody getting or not? But if I gave the SB in the SI unit, so SW also I have to put in the SI unit. So only by mugging the formula MS, there will be the problem. Everybody got or not? Okay. So SI unit of water equivalent I can say is kg, because it represents the mass, and mass SI unit is what? Kg. So water equivalent SI unit is what? Kg. Okay. Completed. Okay, now some question we will do. What I said, find the ratio of the thermal capacity of the two solid sphere if ratio of their radius is 1:2, ratio of the density is 2:3, and the ratio of the specific heat is 2:1. We have to find the ratio of the thermal capacity. Okay. So thermal capacity, we learned the two relation. One basic definition, Q by delta theta, and other we learned M into S. Thermal capacity is the M into S. So here I have not given any heat data. I have not given any heat data. It means I cannot go from the Q by delta theta. So then next formula what I will use, H is equal to MS. Okay. Then H1 by H2. What I can write, H1 by H2 is the M1S1 by M2S2. I have not given the mass ratio. So mass I can write as a volume into density. So this will be V1 rho 1 S1 upon V2 rho 2 S2. Okay. Now V1 by V2. What is the volume ratio? Radius ratio I gave 1:2 and I gave a sphere. So what is the volume? 4 by 3 pi r cube. Then this I can write as R1 by R2 whole cube into rho 1 by rho 2 into S1 by S2. What is the R1 by R2? R1 is to R2 I gave 1:2. So then it will be 1 by 8. Everybody got? Density ratio I gave 2:3. So 2:3. And the specific heat ratio is the 2:1. Okay. Now 2 2s are 4. 4 2s are 8. Then we got the ratio what? 1:6. Completed? Most of the students got the answer. Okay. Second part, suppose I am saying if both sphere is made of same substance or same material, then find ratio of thermal capacity per unit volume. Suppose radius ratio also I have not given. I have not given, only one thing I gave, both solid sphere is made of the same material. Okay, I have not given the radius ratio also. And I'm asking if both sphere is made of same material, then find the ratio of thermal capacity per unit volume. Okay, per unit volume. So for that, whether I gave the radius ratio or not doesn't matter. Suppose I have not given the radius ratio. It means what I need? I need the ratio of H by V. H by V. Okay, I don't need H1 by H2. I need H by V ratio. It means I can say what? I need H1 by V1 and it is what? H2 by V2. Otherwise, suppose I am writing X as a H by V. Then I need what? X1 by X2. X1 by X2 ratio. Who will say what is the answer? If the both solid sphere is made of same material, then what will be the ratio of the thermal capacity per unit volume? What is the ratio of the thermal capacity per unit volume? Tell fast. What is the ratio of the thermal capacity per unit volume? No answer. Okay, one answer I got. Somebody is saying 1:1. Somebody is saying 2:1. Okay, 1:1. Okay. Who is getting the 2:? Okay, I got what they did. Okay, D1 by D2. Okay, somebody is giving the answer in the terms of symbol. Okay, 2:1. Because you are taking, I think, density ratio or specific heat ratio. Okay, now listen. Answer is 1:1. Because I need H by V. Okay, so H by V. H by V, what I can say? H by V is equal to rho into S. Okay. We know that I said one thing, solid sphere, both are the solid sphere and same material. Solid sphere, same material means density will be same because the density depends upon the substance. I'm saying same material I took, and solid sphere I gave. Volume, whether volume same or not doesn't matter. Tanuj, volume same or not doesn't matter because I'm asking per unit volume. So whether it is same or not doesn't matter because H by V will be what? Rho into S. So basically we have to say the ratio of rho S, rho 1 S1 upon rho 2 S2. Okay. Both are the solid sphere. Okay, solid sphere and made of same material. Then I can say density will be same because density depends upon the material. Second, specific heat. Specific heat also depends upon the material. Specific heat also depends upon the material, and material I gave same. So rho same, S same. It means H upon V will be same. So ratio of the thermal capacity per unit volume will be what? Same. It means 1:1. Are everybody getting? Okay, so whether the volume same or not doesn't matter. Why I asked the per unit volume? So per unit volume, so volume is different or same. Ultimately, volume will go with H by V. Now here what I'm getting? Rho S. It means I need the ratio of rho 1 S1 upon rho 2 S2. And solid sphere given same material, it means density same. Because maybe if I give one is the solid, one is the hollow, then there will be the problem. Okay. Completed? Okay. Next problem. If a body absorbs 2000 joule heat to increase its temperature by 2 degrees C, then find its water equivalent. Tell fast. What I have given, if the body absorbs 2000 joule of heat to increase its temperature by 2 degrees C, then what is the water equivalent of the body? So here I gave the heat and temperature change and I'm asking water equivalent, then which relation we will use? Q is equal to MW SW delta theta. Okay. How much heat body absorbs? Same water equivalent absorbs. So heat I can write for the absorbed by water. Okay. Q what I gave? 2000 joule. MW I want to find. Okay. SW now here I am using in joule. Everybody getting or not? Then option is like suppose you want to find the mass in kg. After that we can convert into the gram. So SW what I will put? 4200. Suppose I am following the SI unit. Okay. Delta theta what I gave? 2. Now 2 and this it will become 1000. 1000 then 0 0 0 0 cancel out. So MW what I got? 10 by 42. 10 by 42. 10 by 40 is 1 by 4. 1 by 4 is 0.25. Slightly less than that. So we can say 0.24. Which unit? Kg. Why? I am following the SI unit. If they given the answer in the options in the gram, so 0.24 into 1000, you will get the 240 gram. Everybody got or not? Tell fast. So here I have not used any formula of the water equivalent. I just use the concept of the water equivalent. Means water equivalent is it will absorb same amount of heat as that of body for same temperature change. So whatever the heat absorbed by the body, same water equivalent will absorb. From that I got this. Okay. Understood? Tell fast. what I gave, if the mass of the body is 2 kg and specific heat is the 1050 joule per kg degree C, then we have to find the water equivalent of the body. So here I gave the mass, I gave the specific heat. Then which relation I will use? MW SW is equal to MB SB. Okay, I need the water equivalent, means I need the MW. So MW, what I can say? Mass of the body I gave 2 kg. Specific heat I gave 1050. Now in which unit I put the specific heat? Joule per kg degree C. So SW also I have to put in that unit, and in that unit what is the SW? 4200. Okay, now 0 0 cancel out. 105 forza, it will be 420. Then what we got? 1 by 2. 1 by 2 means 0.5. Which unit? Kg. Why? I am following the SI unit. So then what is the water equivalent we got? 0.5 kg. Completed. Now orally we will not solve, I will not write the problem. Suppose I am saying mass of the body I gave 2 gram. Mass of the body I gave 2 gram and specific heat I gave 0.5 calorie per gram degree C. Directly you will say the answer. I am not writing on the board. Mass of the body I gave 2 gram. In the place of 2 kg I gave 2 gram. And specific heat I gave 0.5 calorie per gram degree C. What is the water equivalent? What is the water equivalent? Mass of the body is 2 gram. Okay, I will write on the board. Mass of the body is 2 gram and specific heat S is equal to what? 0.5 calorie per gram degree C. Then what is the water equivalent of the body? Then what is the water equivalent of the body? Are nalayak, what I gave? Mass of the body I gave 2 gram. Mass of the body I gave 2 gram. So I will get 1 gram. Okay. So then in that case again MW. Then MW is what? MB. MB is 2 gram. Specific heat is what? Calorie per gram degree C given 0.5. Then SW also I will put 1. Okay, then what I will get? 1. In which unit? Which unit I follow? CGS, or I can say mass I put in gram. So here I will get directly in gram. Completed? Why you are saying somebody was saying 1 kg? Understood? Okay. Completed? Suppose I am saying 100 gram of substance is heated and the graph for the heating I have shown. Okay, x-axis I plotted the heat, y-axis I plotted the temperature. Then I am asking find the thermal capacity of the substance, one. Second I am asking what is the specific heat. What is the specific heat, and second I am asking what is the thermal capacity. So listen, directly by the formula also we can get the answer. But what is the purpose for this problem? When I'm plotting the heat on the x-axis and the temperature on the y-axis, okay, so everybody has to know in this what slope will represent which quantity. Suppose I plotted the graph between heat and temperature, then graph I'm getting the straight line. Then here's slope which represent which quantity that we have to know. So here, if I plotted the heat on the x-axis, heat on the x-axis, temperature on the y-axis. So for a small heat, I can say dq. dq is small heat. For the small heat, I can say ms into d theta. Okay, q is equal to ms theta. Q, I am taking a small amount of heat. That's why I'm writing dq. dq is the ms into d theta. Which quantity I am plotting on? This already in the basic mathematics I said. Which quantity we are plotting on x-axis that we will replace with x. Which quantity we are plotting on y-axis that we can replace with y. So here d theta, dq heat I am plotting on x-axis. So this I can replace with x is equal to ms. And temperature I am plotting on y-axis. So this I can replace with y. Okay. Now I got y is equal to 1 by ms into x. Okay. Now if you see this equation, y is equal to mx. In the place of slope, what you have? In the place of slope, what we have? Tell fast. In the place of slope, what we have? Slope is equal to 1 by ms. 1 by ms means 1 by heat capacity. 1 by heat capacity. So remember that if we are plotting the heat on the x-axis and the temperature on the y-axis, then slope of the straight line will be reciprocal of heat capacity. Reciprocal of heat capacity. This everybody got or not? So what is the slope here? Reciprocal of the heat capacity. Okay. Now I can do this problem by using the slope also and without using the slope also. But what I said, slope we have to know. That's why I said. Okay. Okay. So if I am doing by using the slope, okay. So what is the slope of this line? I can say slope is the tan theta opposite upon adjacent. Opposite is what? 8, adjacent is what? 400. Then I can say what? Slope is equal to 8 by 400 and slope I know 1 by heat capacity, 1 by h. Now this will become what? 8 5s are 40. So h value what I got? 50 calorie per degree C. This everybody got or not? So h value what we got? 50 calorie per degree C. Okay. Second, I am asking the specific heat. So specific heat I can find by h is equal to what? ms. H what I am getting? 50. Mass what I gave? 100 gram. S I have to find. So S what you got? 0.5. Which unit? Calorie per gram degree C. So S what we got? 0.5 calorie per gram degree C. Tell fast. Everybody got? Okay. Okay, without using slope, how we can find? So if you see the graph, it absorbs 400 calorie of heat, then the temperature changes 0 to 8. This we will take not given, and we will consider origin as a 0. So 0 to 8. So when it absorbs 400 calorie heat, then temperature changes what? Delta theta is the 8. Then directly I can say, without using slope I am saying, so how much heat absorbed? Q is equal to, I know that H into delta theta. It absorbed the 400 calorie of heat when temperature changes 8 degree C. Then what is the H value I got? 50 calorie per degree C. So without using the slope also we can find by this way. But why I said the slope? Because we have to know that if we are plotting the heat on the x-axis, temperature on the y-axis, then slope represent what? Reciprocal of the heat capacity. Okay. Completed. Okay. Next problem. If container filled with 2 kg water at 20 degrees C. Then find amount of heat required to increase its temperature by 50 degree C. If thermal capacity of container is 1000 joule per degree C. Okay, so what I said, if the container is filled with 2 kg of water at 20 degrees C, and then we have to find the amount of heat required to increase the temperature of water by 50 degrees C if the thermal capacity of the container is 1000 joule per degree C. So if no data given for the container, it means we have to ignore the heat absorbed by the container. Or in the problem they are saying ignore the thermal capacity of container, or they are saying thermal capacity of container is negligible. It means container we should not give any heat to the, we should not take any heat absorbed by the container. Why? H is negligible, so Q is equal to H delta theta. Q is equal to H delta theta. If H is negligible, then Q will be negligible. So heat absorbed by the container we will take negligible. If in the question they given thermal capacity of the container is negligible. Okay, so container temperature will change, but it will not absorb the heat. Heat absorbed by the container we will take 0. But if they given the thermal capacity of container, it means when we will give the heat to the water, container will also absorb the heat. So who will absorb the heat in this problem? Container as well as water. In between who came? Hi Manish sir. Hi. Understood or not? Are say fast. Tell fast. So if they given the thermal capacity of container, water equivalent of the container, it means we have to give the heat to the container also. We have to heat absorbed by the container also. Okay. Now here to get the total heat, we have to find the heat absorbed by the water as well as heat absorbed by the container. Okay. Now who will say what is the delta theta for water? In this problem, what is the delta theta for water and container? What is the delta theta for water and container? What is the delta theta for water and container? Okay, one answer I got. What is the delta theta for water and container? Initial temperature given 20 degrees C and the temperature is increased by 50 degrees C. What is the delta theta for container and the water? Water 50, container 20. Okay, somebody saying 50. So for both, Tanuj, how the container and the water temperature will be different? Ultimately, water is in the container. So for the thermal equilibrium, otherwise container will start taking the heat from water or water will start taking the heat from the container. So I said already, increase by means delta. So then here I gave the 20 degrees C initial temperature. 20 degrees C initial temperature I gave. But I'm saying temperature is increased by. By means delta directly. So it doesn't matter what is the initial temperature I gave. Everybody getting? If I directly gave by, that is the difference between small word create the difference. By and 2. If I'm saying temperature is increased to 50 degrees C, it means final temperature is 50 degrees C. Then I will take the delta theta is 50 minus 20, that is 30. If I'm saying temperature is increased by 50, means delta theta is 50, final will be 70. Final will be 70, doesn't matter what is the final. So directly delta theta what we will take? By means change, then we will take 50. So delta theta for container as well as water. So delta theta for container and water, what I will take? 50 degrees C. So here 20 degrees C I just gave to confuse only. Okay. Now heat absorbed by the water. If I am writing the heat absorbed by the water, so heat absorbed by the water, what is the mass of water? 2 kg. Okay. Into, I am using the mass in kg, then specific heat I will put what? 4200 into delta theta. What is the delta theta? 50. Now 1, 2, 3. This 1000 I am putting in kilo. Okay. So then what I will get? 5 2s are 10. 5 2s are 10 and then here 420 kilojoule. Okay. So heat absorbed by the water, what we got? 420 kilojoule. Okay. Now heat absorbed by container. Container thermal capacity, what I gave? 1000. So I can say H into delta theta. What is the H I gave? 1000. And what is the delta theta? 50. 1000 I am taking in kilo. Then this I can say what? 50 kilojoule. Okay. Now what is the total heat absorbed? Total heat required. So total heat I can say what? 470 kilojoule. Okay. So what is the total heat required for this? 420 plus 50, that will be 470 kilojoule. Okay. If I have not given any data for container, then directly we can take the heat absorbed by the container is 0. Okay. Completed. Okay. Now next concept is what? Phase change or transformation. So phase change, 2-3 phase change, and everybody know also in the junior classes we have learned, like melting. What is the melting? So conversion from solid state to the liquid state. What is the vaporization? Conversion from liquid state to the vapor state. Okay, what is the condensation? From vapor state to the liquid state. What is the sublimation? Sublimation is the conversion from solid state to the gaseous state. This everybody know or not? So melting, conversion from solid to liquid. Vaporization, conversion from liquid to the gas. So I think no need to write. So melting, solid to liquid. Okay. Vaporization, liquid to the gas. Sublimation, solid to the gas. I have to write or everybody know? Tell fast. Anybody want? Then they can say I will write on the board. So 3, 4 I said, melting solid to liquid, vaporization liquid to gas, sublimation solid to gas, and condensation liquid, vapor to the liquid. Everybody know? Okay. Then I will define the temperature only, like melting point, boiling point. Okay. So first one is what? Melting point. Now who will say what is a melting point? So melting point, one definition we know basic junior classes what? Melting point is a temperature at which solid melt. Okay. But that is not only the sufficient. So listen, melting point is what? Suppose I put the ice block. I took one container, in that I put the ice block and I put suppose in the room or you put in your room. Okay. Then what will happen? Suppose we took the ice block and we put in the container and we put in the room. Then what will happen? If we put the ice block in the container and then we put in the room, then what will happen? Ice, immediately it will not melt. It will start melting. It will start melting. Immediately whole ice will get melt? No, it will start melting. Okay. Now when it start melting, so in your container, what you will have? You will have some water, some ice. When it is started melting, so some water and some ice will be there or not? Tell fast. Okay. So in the container we have some water and some ice. Now when melting is going on, till the whole ice will not get melt, temperature will not increase. Temperature will not increase. So suppose we measure the temperature of the water and the ice, whatever. Because some water is there, some ice is there. If I measure the temperature of water or temperature of the ice, then we can say it both will be at 0 degree C. So till the whole ice will not get melt, temperature will not change. Okay. So what is the definition of the melting point? Definition of the melting point is what? The temperature at which solid and liquid state exist in the thermal equilibrium. The temperature at which solid and liquid state exists in thermal equilibrium, that temperature is called the melting point. Okay. Solid and liquid state means like ice and water. What is the meaning of thermal equilibrium? Both temperature are same. Both temperature are same. So the temperature at which solid and liquid state exists in thermal equilibrium, that is called melting point. Okay. Everybody got? And this everybody know, melting point of ice. Melting point of ice at 1 atm pressure. Melting point of ice at 1 atm pressure. What is the value? 0 degree C. So by default, if they not given the pressure, we will consider 1 atmospheric pressure. At 1 atm pressure, melting point of ice is what? 0 degree C. So water will freeze at 0 degree C and ice will melt at 0 degree C at 1 atm pressure. That is also called the normal melting point. Normal melting point means melting point at 1 atm pressure. Okay. This everybody got? And this also you have to remember, melting point decreases, melting point of ice, we can say melting point of ice decreases with increase in pressure. So melting point of ice decreases with increase in pressure. Okay. Completed. Like suppose I am saying at 1 atmospheric pressure, ice will melt at or water will freeze at 0 degree C. But when we increase the pressure, then water will freeze or ice will melt at negative temperature. So on increasing the pressure, melting point decreases. On increasing the pressure, melting point decreases. Decreases means it is 0 at 1 atm. Now I am increasing the pressure. So it decrease means it will go to the negative value. Okay. So we can say what? Melting point depends upon the substance and the pressure also. Why? For ice, melting point is 0 degree C. For other substance, melting point will be different. So melting point depends upon the substance and the pressure. Can we say or not? Melting point depends upon the substance and the pressure. Okay. Number 2, boiling point. So what is a boiling point? So one thing, the temperature at which the liquid start boiling, that is called the boiling point. Okay. Vaporization, everybody know, conversion from liquid to the vapor state is called the vaporization. Okay. This everybody know. Vaporization we can categorize two type. One is the evaporation, one is the boiling. Okay. What is the evaporation? Evaporation take place at all temperature. Means when the liquid will convert into the vapor phase, that will carried out at all temperature. If you in the night you put the water in the glass and you cover with some plate, in the morning you will see some vapors will get stick with the plate. So that is the evaporation. Evaporation means it will take place at all temperature. It will take place at all temperature, and rate of evaporation will increase with increase in temperature. It means summer if you are putting the plate on the water, then summer you will get more vapor. In winter you will get less vapor, but you will get the vapor. So vaporization, evaporation take place at all temperature. Its rate will increase with increase in temperature. Okay, but what is the boiling? Boiling is the boiling take place at particular temperature. Boiling take place at particular temperature at which vapor pressure become equal to the atmospheric pressure. So what is the boiling point? Boiling point take place at particular temperature, when vapor pressure become equal to the atmospheric pressure. Everybody got? Or another way we can say the temperature at which liquid and steam we are generally calling as a vapor, but better is what? Steam. So liquid and steam exist in thermal equilibrium. Okay, understood? So what I said, it is the temperature at which liquid and steam, generally we will write as a vapor, exist in thermal equilibrium, or we can say, or it is the temperature at which vapor pressure is equal to atmospheric pressure. That's why if you remember I said old thermometry we were using the two reference temperature, ice point and boiling point, but in modern thermometry we are not using that because their value changes with the change in the pressure. Inside the pressure cooker water boils around the 130 140, but in hilly area pressure is less, so that's why water start boiling at low temperature around 70 80 it will start boiling. Remember? Okay, so vapor pressure is equal to the atmospheric pressure. So which quantity it depends? So I can say boiling point of water at 1 atm pressure is equal to 100 degrees C. So that is called the normal boiling point. Normal boiling point. What is the normal boiling point? Boiling point at 1 atm pressure, and that we know 100 degrees C. And on increasing pressure, boiling point increases. Okay, on increasing the pressure, boiling point increases. So reverse for the melting point. On increasing the pressure, melting point decreases, boiling point increases. Okay. And boiling point depends upon the substance. Different substance, different boiling point we will have. Okay. Completed. Okay. Next is the latent heat. So how we are defining the latent heat? So latent heat we are defining L is equal to what? Basically Q by M. If I am taking M is equal to 1 unit, then we can say what? L is equal to Q. Okay. So how we are defining the latent heat? Latent heat. So it is the amount of heat required to change the state of unit mass of substance at constant temperature. So listen, what I said, melting carried out at a constant temperature, boiling carried out at a constant temperature. So phase change take place at constant temperature. During the phase change, temperature does not change. Like I put the ice here and then ice started melting. Till the whole ice will not get melt, temperature will not increase. Temperature will not increase. So that's why I said here it is written. It is the amount of heat required to change the state of unit mass of a substance at a constant temperature, because state change will take place at constant temperature. During the state change, temperature will not change. Everybody got or not? So from this latent heat definition, I can say what is a Q? So for state change, heat, I can say Q is equal to what? M into L. So two heat we have learned. One is the ms delta theta, one is the ml. Ms delta theta we are writing when the temperature of the substance is changing by delta theta. So for the temperature change, always heat we can write ms delta theta. And for state change, always heat we can write Q is equal to ml. During the state change, temperature will not change. This everybody got or not? So state change will carried out at a constant temperature. If the melting is going on, it will carried out a melting point. If the boiling is going on, so it will carried out at the boiling point. But during the state change, temperature will not change. Okay? Tell fast. Understood? So these two values, you know, if I am saying melting point, latent heat of melting of ice, who will say what is the value that we marked up? It is a 80 calorie per gram. Latent heat unit is what? Calorie per gram or joule per kg. Here we can write also unit of L. L is calorie per gram, or we can say joule per kg. SI unit will be joule per kg. Okay. So latent heat of melting of ice is 80 calorie per gram. If suppose I want the SI unit, so calorie per gram conversion factor I said into the joule per kg 4200, then I can say 80 into 4200 joule per kg. So in the problem, when we are following the SI unit, then we have to take the L value in the joule per kg. So we marked up in calorie per gram. How to convert the calorie per gram in joule per kg? By multiplying with 4200. And latent heat of vaporization, that is equal to what? 540 calorie per gram. Okay, this I am writing for the ice and the water only. Other different substance, different values will be there, but generally we are using the ice and water in all the problems. That's why this value we have to remember, but in the question they will give also 540 calorie per gram, and in the SI unit 540 into 4200 joule per kg. Completed? Okay. Now one question we will write. So here what I gave, 20 gram of ice is at minus 10 degrees C. It is placed in the container whose water equivalent I gave what, 10 gram. Okay, water equivalent is at 10 gram. Then we have to find the amount of heat required to convert whole ice into the steam. You have to convert the whole ice into the steam. Now listen, this type of problem, when the state change as well as temperature change is involved, okay, first write all the phase transformation and all the temperature change, then start adding the heat. Reason is what, if you start writing like this way directly, you are taking the heat, so maybe in between any phase change or any temperature change you will miss. Okay, so here two phase change, two temperature change involved. So what we will write, first we will write all the transformation from ice to the steam. Okay, so first what I gave, ice we have at minus 10 degrees C. Okay, how much mass I gave, 20 gram. If I start heating, who will say what will happen first? If I start heating, then what will happen? Ice will start melting. Ice is at minus 10 degrees C. If I start giving the heat, ice will start melting. Tell fast. If I start giving the heat, ice will start melting. If I start, no, Nalayak. Ice will melt at melting point only, na? Because if they not mention the pressure, so pressure we have to consider the atmospheric. And 1 atm pressure, what is a melting point? 0 degrees C. So first it has to go to the melting point, then it will start melting. Okay. So first, when we start giving the heat, here ice is at negative temperature. First it will go to the melting point. What is the melting point of ice? 0 degrees C. So first it will go to the ice at 0 degrees C. Okay, now you can say ice and ice to ice, no state change, only temperature change, minus 10 to 0. Then we can say heat is what? Ms delta theta. Okay, S we will take the specific heat of ice because we are increasing the temperature of ice. Okay, now whole ice reach to the 0 degree C. Okay, now ice reach to the 0 degree C. If I am still giving the heat, then ice will start melting, and during the melting temperature will not change. So ice 0 degree C will convert into the water at 0 degree C. 0 0 temperature does not change, only state change. For state change heat we are writing what? ml. Okay, up to this. Okay, now I have water at 0 degree C. Still I am heating, still I am giving the heat, temperature of water will start rising and water will go up to the boiling point. So here water 0 degree C, it will go to the water 100 degree C because I am asking heat required to convert into the steam. Okay, so water 0 to water 100. Water to water, no state change, only temperature change, ms delta theta. And this m I will take the specific heat of water. Okay, now I have the water at 100 degrees C. Still I am giving the heat, so this water will convert into the steam now. So water at 100 degrees C, it will go to the steam at 100 degrees C. Now you can see no temperature change, only state change, water to steam. For state change heat we will give what? mlv. Okay, this state everybody got? Completed like this. Then when you will write, then all the heat, then after that you can add easily. In that you will not miss any state change. Otherwise directly you are writing, so you can miss. Okay. Now total heat absorbed by the ice. First ms delta theta. How much mass? 20 gram. Specific heat of ice in calorie per gram unit 0.5. Okay. Delta theta is what? Minus 10 to 0 means into 10. Okay. This everybody got. Plus here state change ml, mass of water, mass of ice is 10, L is what? 80. Plus water to water, here heat, increase in temperature of water, ms delta theta, 10 into 1 into 0 to 100 means delta theta is what? 100. Plus here water to steam, state change ml means 10 into latent heat of vaporization is what? 540. So this is the total heat absorbed by the ice. Now can you add? This become 5. Then it is about 100. Anybody got value? Plus this will be 800. Plus this will be 1000. Plus this will be 5400. So 54 plus 64, 64 and then 64 and 8. 72, 73 I think. 5400 plus 1000, 6400, 6400 plus 800, 7200, 70. Okay, mass is 20. Okay, mass is 20 gram. Here I started taking 20. Okay. Mass is 20 I gave, no? Then that is equal to what? Here, that is 100. That is okay. Here what we got, 8 to the 16 means 1600. Okay. Anybody got? 7. No, mass is, I think mass I gave 20 gram, na? Water equivalent I gave 10 gram, mass of ice is the 20. So mass of ice I am writing here. So then here we will get what, 1600. Here what we got, 2000. Plus here what we got, 54 means 10800. Nobody gave the answer. So 1 means 12800, 12800. How much you are getting? 12800 and 1600 and then 100. So 007 plus 8. 5, 1, then you will get 4, 14500. Yes. So that will be equal to what? 14500 calorie. Everybody got? Sir, what mass 10 gram you written 20 gram? 20 gram I have given the mass of the ice. You can see the problem now. Here I give, if the 20 gram mass of ice at mass. First I am showing the transformation for ice. And what is the mass of the ice given? 10 gram, 20 gram. So first I am solving for the ice. That I will come later. So this 14500 calorie is the heat absorbed by the ice only. First I have written only for the ice. Now I will write for the container. Meghna. That is the water equivalent of the container. Right now I am not writing the heat absorbed by container. I am writing the heat only absorbed by the ice. So total heat absorbed by the ice from the minus 10 degrees C to the steam, how much? 14500. Understood or not? Now I am going to write the heat for the container. So heat for the container, what I can say? So listen one thing. Container state change will not be there. Container is containing the ice. Ice state change is there. But container, what will happen? Only for the container, only temperature will change. Container will not evaporate. Container will not convert into the vapor. Okay. So for container, only temperature change will be there. So what is the initial temperature of the container? Minus 10 degrees C, because it is containing the ice at minus 10 degrees C. What is the final temperature of container? It contains the steam 100 degrees C. So final temperature of the container is 100 degrees C. So what is the delta theta for container? Delta theta for container. Tell fast. What is the delta theta for container? Minus 10 degrees C to the 100 degrees C. Then we can say what? 110 degrees C. Okay, so for container, we will only write the heat for the temperature change, because container state change will not be there. Now I gave the water equivalent of the container. So I can find by MW, SW, delta theta. Water equivalent I gave 10 gram. SW I will take 1. Delta theta what I got? 110. So how much I got? 1100 calorie. So how much container absorb? 1100 calorie. Okay, so this 1100 calorie by the container and 14,500 by the ice. So total heat required is what? What is the total heat required? So Q total we can say what? 14500 plus 1100. That will be equal to what? 15600 calorie. Completed. If any data I have not given for container, it means we will only consider the heat absorbed by the ice. But here I gave the water equivalent of the container. It means whatever heat we are giving, the heat container will also absorb the heat. Okay. Completed. Up to this, okay. In the same problem, okay, one more thing I'm adding. If for above process heater of power 2 kilowatt is used, then find time taken in the process. So how much total time the heater will take in the above process if we are using the heater of the power 2 kilowatt. One more thing, listen first. Suppose I am saying maybe in the evening, if any class or any meeting will not be there, then 7:30 around I will take the class. I'll send the message also. Okay. So be prepared if any meeting is there. So 7:30 only the mixture problem, to discuss the mixture problem and heating curve. In the evening, 1 hour around, I will take the class. Timing is around 7:30. If any meeting is there. Okay, I will send the message also, exact timing. Okay. Completed. Okay, so now here I am saying if the above process we are using the electric heater of power 2 kilowatt, then how much time required? So now listen, here we are using the 2 kilowatt. Watt means what? Joule per second. What is the joule per second? Okay, kilo means 1000, means we are using 2000 joule per second. What is the power of the heater? 2000 joule per second. Okay. So we know that energy energy we can write as a power into time. Energy we can write power into time. So then heat we can say Q is equal to power into time. Okay. Everybody got? Power I can say PT is equal to, what is the total heat required? 15600 calorie. 15600 calorie. Okay. Power I can write what? 2000 joule per second. 2000 joule per second into time. Okay. But right hand side I have the energy in calorie. So first I will convert into the joule, then only I can equate the joule and joule. In joule how much we will write? 15600 into 4.2. Then I got in the joule. Okay. Now 0 0 0 0 cancel out. What is the T we got? 156 into 4.2 by 2. So that will be equal to what? 2.1. Multiply it, you will get the time in second. Completed. Okay, so what I said, if for above process we are using the electric heater, then how much time it will take for the above process? So heater, what is the power I gave? 2 kilowatt means 2000 joule per second. It means heater is giving in 1 second how much energy? 2000 joule. Heater is giving 1 second how much energy? 2000 joule. Okay. Now in 1 second 2000, so suppose T second how much? 2000 into T. Okay. That heat has to be equal to the heat required. Heat I calculated in calorie, 15600 calorie. So I convert into the joule because left hand side I am using the joule. After solving we will get. Okay, this will be 20 also, no? 20. Then it will come 15.6 means 32.76. Here it will be the 10. Now I can say 15.6 into 2.1. After solving, what you are getting? 32.76 second. Okay. Now all states and everything we know, only the all formula also mostly we know, only the heating curve and the mixture problem we will discuss in the evening. Okay. Timing I will send at least 1 or 2 hours before. Okay, but approximate timing I said around 7:30. If no any meeting is there, otherwise I will prepone. Okay. Okay, then bye bye. Next class.
देखिए बताया